This is problem number 9 from section 2.3. In this problem it says, assume that in 2003 consumers used credit and debit cards to pay for 40% of all purchases. This percentage is projected to be 60% in 2011. Part A, find a linear function that models the data, where x is the year and p of x is the percentage. So we're going to start in part A by finding a linear function, meaning we need two coordinates. They do give us two coordinates. They say 2003, it was 40%, and 60% in 2011. Okay, so we can say 40%, and I'm going to use the decimal version. Oops, first I should say 2003, comma, 0.40, right? We always want to use the year for x. And then for the other coordinate, we're going to say that that's 2011, 0.60. Okay, let's go ahead and use then our finding slope and point slope form to write an equation. So we're going to start by labeling this x1, y1, x2, y2. And m is our slope here, so we're going to say 0.60 minus 0.40 over 2011 minus 2003. This gives you 0.20 over 2011 minus 2003. That's 8. 0.2 divided by 8 is 0.025. So this is 0.025 for our slope. All right. From there, we can write our function now. So we can use point slope form, y minus y1. We can say y minus 0.40 equals 0.025 x minus 2003. If we want to put this in slope-intercept form, we can go ahead and distribute. Let's go ahead and distribute that. I think that makes sense. So we're going to get y minus 0.40 equals 0.025x. We're going to take 0.025 times 2003. That's 50 so minus 50.075. Add the 0.4 over, we get y equals 0.025x. We're going to add 0.4 to this. So we're going to say minus 49.675. So this right here is our linear function that models the two data points that we were given. The only difference I need to use is this p of x. I need to replace y with p of x for this problem because they want us to use function notation instead of using y. So we'll go ahead and throw that in there. You know it's still y anyways, but we're just using p of x to be more specific, function notation. Part B then, they say, estimate when this percentage was between 45% and 55%. So if they want to estimate when we're between two different percentages, they're asking us to use a compound inequality, and we're trying to take this, I guess we could write it this way. We want 0.45 to be less than or equal to the percentage p of x, which is less than or equal to 0.55. I think that's the best way to figure it out. That's what they're saying. When is the percentage between those two numbers? Percentage p of x. That means we can use this equation in there to solve. So we're going to say 0.45 is less than or equal to, we're going to say 0.025x minus 49.675, and that's less than or equal to 0.55. Let's go ahead and add this to each side. So we're going to add 49.675 plus 0.45 gives you 50.125, which is less than or equal to 0.025x, which is less than or equal to, if we add 0.55 to 49.675, we get 50.225. Finally, let's divide each side by 0.025. When we divide 50.125 divided by 0.025, we get 2005 for the year, less than or equal to, now we'll do 50.225 divided by 0.025, we get 2009. I'm going to rewrite this. That's 2005 less than or equal to x less than or equal to 2009. Meaning from year 2005 to 2009, our percentage was 45 to 55%. So between these 2 years, that's when the percentage was 45 to 55%.